Alright, today we're going to be taking a look at our notes, which is finding limits techniques. This is where we organize all the techniques thus far that you should know how to find the limits to. The learning targets, I can find limits using various techniques. It's not written here for you, but please write that in at the top of your note catcher that you have with you today. Alright, so right here at the bottom of your handout, the first technique that we always want to use with limits is substitution. That is the most direct method. So let's go here. So we're going to go ahead to find the limit of 2x plus 1. All we're going to do is substitute negative 1. And again, I put here, recall if you don't get division by 0, just remember to plug in. So anyways, let's go ahead and plug in. If I plug in negative 1 into this function, I should get out negative 1. Alright, next one. Here, I don't get division by 0, so I'm good to plug in. Let's go ahead and plug in 3. 3 squared minus 4 is 5. Alright, let's check on this one. So, let's first check, do I get division by 0 or not? So I'm going to plug in 2. Let me just check the bottom. So if I plug in 2 right here, I get 2 plus 3, that's 5. Because the bottom in my denominator does not give me 0, then all I got to do is just plug in. So I'm going to do 2 squared plus 5 times 2 minus 6 on top, and then 2 plus 3 at the bottom. I get 8 over 5. And that's it. That's going to be my answer here. Again, let me repeat. Because you don't get division by 0 here, you can just directly substitute. All right. This technique, the next technique is called the factoring technique, which you all have been used to. The factoring technique is used when you do get division by 0. Let's go ahead and check this out. You see this negative 2 here? I know that if I plug in negative 2 into my denominator here, I get negative 2 plus 2, and we know that negative 2 plus 2 will give me a 0 down here in the denominator, irrelevant of the fact of whatever the heck I get up here. I just know that I'm going to get a 0 down here, therefore that is not allowed. So what I have to do first is I have to factor. I'm going to go ahead and factor this top portion using my diamond method or whatever method you're comfortable with. So if I use diamond method, this top factors into this. I know I can cancel out x plus 2 and x plus 2 because again we have multiplication on top, so we can cancel. We're left over with x minus 1. Great. So therefore negative 2 plugged into x minus 1 is just going to be negative 3. Because again, these guys got canceled and all we're doing is substituting negative 2 into this expression. Let's move on to this next sample. Again, the first thing you always want to check is, do I get division by 0? So if I plug in 5 into my denominator here, I get 5 minus 5. That will give me a 0. That's a problem. Therefore, we must factor this top portion. So then let's go ahead and use our diamond method, or use the fact that a squared minus b times a plus b equals a squared minus b squared. So I know the top factors into a plus b and a minus b. In this case, our b is 5. Great, so we factored the top. The x minus 5s cancel, and I'm left over with x plus 5 on top. Now I'm just going to plug in 5 to get 5 plus 5 is equal to 10. That's it. That's my answer. This next example, again, you always want to check, do you get division by 0? I know that 4 minus 4 right here will give me division by 0. Therefore, I know I got to use my diamond method. But remember, because there's a 3 up front here, you got to use your modified diamond. So using your modified diamond method, this is what you should get out as your product. And then you want to cancel out your x minus 4s. Once you cancel this out, you're left over with 3x minus 5. You're going to plug in your 4. 3 times 4 minus 5 should give you a 7 as your answer, and that's going to be your limit. Alright, so we've covered substitution and factoring methods. Now let's move on to the more complex methods. This is multiplying by the conjugate technique. So this technique here is a more complex method. This right here we have talked about already. We've had some practice on this. This one probably will need a little more discussion, but let's go ahead and go through it. I feel like as long as we go through these examples and I walk you through them, you should be fine. Anyways, so the technique is usually wherever you see the square root, you want to go ahead and multiply top bottom by the conjugate of this portion here that contains the square root. So I know the conjugate is just the square root of x plus 4 instead of a minus 4. So let's go ahead and multiply the top and bottom by the conjugate. All right, So then this top portion is just going to stay as x minus 16 times the square root of x plus 4. The bottom, using the rule, we're going to get the square root of x squared minus 4 squared. And the top, like I said, just stays. The bottom, we're using that property, the a minus b times a plus b, right? A squared minus b squared. Luckily, the square root of x squared is just x because the squared and the square root cancel each other. The 4 squared is just going to give you 16. Awesome. So as you can see here, by multiplying by the conjugate, I get rid of the x minus 16 and I get rid of the x minus 16. And I'm just left over with the square root of x plus 4. So great. So the square root of x plus 4, all you got to do is plug in your 16. The square root of 16 is 4. 4 plus 4 is just going to give you 8. One thing I forgot to mention, guys, is that I am multiplying by the conjugate because I still am getting division by 0. That's always something you want to check first because I know if I plug in the square root of 16 as 4 minus 4 will give me division by 0. So that's why I'm doing this conjugate technique to get rid of the denominator so that I can plug in. So yeah, just as I mentioned. All right, next one here. All right, so let's pay attention to this type of problem. So here I know if I plug in 1 or if I substitute 1, I get 1 minus 1 in my denominator. Again, that's going to give me a 0, so I have a problem. Therefore, I know, because there's a square root, that I must use the multiply by the conjugate technique. In this case, though, the conjugate part is not in my denominator, it's actually in the numerator. So I'm going to first find the conjugate of the numerator and multiply top and bottom by my fraction by that. So take a look here. This is what I mean. This is the conjugate of the numerator because that is where the square root part is found. So you always want to multiply by the conjugate of wherever the square root portion is found. It does not always have to be in the denominator like in this problem. All right, let's go ahead and let's put these together. And then I'm going to go ahead and do these together. Here, we're going to have an a minus b, a plus b. So we're going to use that special property, and this one will just combine. Let's take a look at that. This is how it should look like. The bottom, you just multiply across like so. And at the top, this is my a squared minus, and then my b squared, which is 2. It always when a and b is the same. All right, so squared gets rid of the square root. This 2 and this square root will cancel, and this will become minus 4. Let's see what that gives me. Good. Now, let's go ahead and combine like terms on the top here. So 3 minus 4 is going to give me x minus 1. Great, as you can see, luckily, I can already cancel my x minus 1s, which is awesome. I'm going to cancel these out. One thing though, before you cancel that, you must be careful. When you cancel these out, what you're left over with on the top is just 1, and at the bottom is this. This is what you're left over with. So this should not somehow automatically move to your numerator because that will give you the wrong answer. All right, so now you're left over with this. I think we are ready, therefore, to now plug in our 1, and I won't get division by 0. Let's see. So 1 all over 3 plus 1, we know that's 4. Oops. Okay. Sorry, guys, I didn't put the answer here. So 1 all over 3 plus 1, I know that's 4. So the square root of 4 is 2. 2 plus 2 is at the bottom. So your answer for this problem is going to be 1 all over 4. So you guys should write 1 all over 4 as your answer. That's after you plug in 1 into here. Great. All right, so this method right here is simplifying fractions technique. So lately in class, we've been working on simplifying fractions. The reason for that is because you must know how to find limits of complex fractions. So that's what we're going to do here in these examples. Finding the limit if you have a complex fraction. So step 1, always make sure that when you're plugging in 0, you get division by 0. This one is, you can directly see that you will get division by 0. So therefore, we know we got to do some simplifying and canceling. And how we're going to tackle this problem is by combining our fractions and see if anything cancels. Let's go ahead and do that. So I'm going to focus on the top right here. I'm going to combine this top portion, and let's see if it gets me anywhere. So what I mean by combining is making sure I get the common denominator. I go ahead and multiply by the other fraction's denominator, and then I get this part. Right here, you got to be careful with this minus. You want this minus to distribute to this x and also to the plus 5. when you combine the bottoms here. So let's go ahead and distribute. So as you can see, I finally combined this into one fraction. The minus distribute to both the x and the 5, and I'm left over with all over x. Awesome. Now the top is going to be 5 minus 5. That'll be left over with a negative x right there. So right here should be a negative x. Let me just quickly add this in. That should be a negative x. And let me just put that in, and then I'll walk you through the answer. My apologies here. And there we go. Anyways, let's go back to where we were. All right, so we end up with negative x here on the numerator, our common denominator, all divided by x because that is what the problem told us to do. Great, so now what I have here is fraction divided by another fraction. If you put this over 1, that's your other fraction. So then we're going to take the bottom, flip and multiply. I color-coded the x's to show you that I can cancel these out, and what you're left over with is just negative 1 all over 5x plus 25. From there, let's go ahead and plug in our 0. I plug in my 0 to get negative 1 over 25. I'm sorry, negative 1, over 25. My bad. There we go. Because if you plug in 0 here, 5 times 0 is 0, and you're just left over with negative 1 over 25. So that's how you do this left side here. Here we go. That is your answer after you plug in your 0. All right, now let's move on to this next problem. So this next one has fractions going on. So again, we want to make sure, do I get division by 0? The first step is you're going to plug in your 2 into, it doesn't have to be to each one. As long as one of them gives you division by 0, then you know you got to do something to rectify that part. So I know that 4 times 2 is 8. 8 minus 8 gives me division by 0. Okay, there's a problem. So what I'm going to do is, since these are fractions, I'm going to try to get a common denominator so that we can simplify the fractions. So let's go ahead and do that. We multiply by the other fraction's denominator, distribute our 1. Remember, because there's a minus there, you got to distribute that minus into both terms to get this. The bottom just stays like so. Now, let's see. So let's combine like terms. So I got a minus 4 plus 8. So we get a plus 4. Now let's see. So nothing canceled yet from the denominator. So because of that, I know I should perhaps factor this top part so that something in the bottom can cancel so that I don't get my division by 0. So let's see what we can do here. Let's factor the top using our diamond method. Great. When I factor the top, I get x minus 2 times x minus 2 if I use my diamond method. And this part right here, a squared minus b squared, is x plus 2 and x minus 2. So I already can see that I can cancel out the x minus 2's there. Great. Let's go ahead and do that. All right. So am I done? Let's see. If I plug in 2 right here, I still get 4 times 2 minus 8, 8 minus 8. I'm still going to get division by 0 because 0 times x plus 2 is still 0. So still a problem. So what can I do? What can I do to try to get rid of that division by 0? So what if I pulled out a common 4 from here? Because I know 4 goes into both. What if I do that? If you do that, you notice that you finally can cancel out the x minus 2's right here. Let's do that to get this. Wow. Now that I have that, let's see if I can plug in 2 finally, and I won't get division by 0. So if I take my 2, I plug it in, I get 2 plus 2, that's 4, times 4, 1 over 16, we've done it. We found the limit without division by 0. This is how you do it. So this last one right here, very complex, but that involves, basically the complex is not the calculus. The complex comes from simplifying the fraction, which is this whole portion right here. As long as you know how to simplify your fraction, then you are good. If you need any help simplifying fractions, like I said, I'm here for office hours. And I believe that was the end of our notes. Now we can get on to the task.